Welcome back. Today, we're going to talk about the single most important program on your computer. You know, the one you're using every single second, but probably never ever think about. And we're going to see how that one piece of software is quietly controlling just how well your machine actually performs.
So, let me just ask you this. What do you think is the most critical program running on your computer at this very moment?
Is it your web browser? Nope, not by a long shot.
Okay, what about that game you pour hours and hours into? Good guess, but that's not it either.
The real answer? It's the invisible engine that's running the entire show from behind the scenes. We are, of course, talking about the operating system.
All right, so let's dive right in. What in the world is an operating system, and what does it actually do? Well, the classic textbook definition says it's a program that acts as an intermediary, a kind of translator that sits between you, the user, and all the physical computer hardware. It's what makes the whole thing usable and efficient.
And this diagram, it shows that role perfectly. You can see the OS sitting right there in the middle. It's the manager that coordinates between the raw hardware, your CPU, memory, all that stuff, and the apps you actually want to use, like your web browser or your word processor.
So really, you can boil it down to two main jobs. First, it's a resource allocator. It has to figure out how to share the computer's limited resources, like CPU time and memory, fairly between all the different programs that are screaming for attention. And second, it's a control program. Its job is to keep everything in line, making sure programs run the way they're supposed to and don't mess with the hardware or crash the whole system.
And yeah, for reasons that are a complete mystery to us, the textbook that some of these fundamental computer science ideas come from uses dinosaurs as illustrations. We don't get it either, but hey, it definitely makes things more memorable.
Okay, so let's see how that resource allocator job actually plays out in the real world, because this is where things get really interesting, especially when you start talking about performance.
Check this out. This is a quote from a user with a beast of a machine. We're talking a Ryzen 5950X, 128 gigs of RAM, and they said that running Windows 11 made their super powerful PC feel sluggish, kind of like an old computer from the XP days that was just riddled with malware. Yikes.
But then, on the flip side, you get this. Here's a user talking about SteamOS, which is built on Linux. They describe the experience as so much smoother and say that features like sleep mode are perfect every time, which was definitely not what they were getting on Windows.
And look, this isn't just about how it feels. We've got cold, hard data. When testing the game Cyberpunk 2077 on the exact same hardware, the Windows version kind of chugged along at 46 frames per second. But on the Linux-based SteamOS, a super smooth 59 FPS. That is a massive 28% jump in performance just by changing the operating system.
So what's going on here? Why the huge difference? Well, a couple of things. Windows is just busy. It's constantly running stuff in the background for automatic updates, for Microsoft Edge, for OneDrive, you name it. SteamOS, though, is a specialized OS. Valve built it for one main purpose, to play games. It's lean, it's focused, and as a lot of people will tell you, Linux in general just tends to have less overhead, which makes a huge difference, especially on less powerful devices.
Now, if the operating system makes that big of a difference for your gaming, just imagine how much it matters for, the entire internet.
Here's a fact that might actually surprise you if you've been a Windows or Mac person your whole life. The massive infrastructure that powers our modern world, we're talking the cloud, servers, the whole DevOps movement, pretty much all of it runs on Linux. And there are some really solid reasons why it's so dominant. First up, automation. Linux was basically built from the ground up to be controlled with scripts and code. Second, those game-changing technologies like Docker and Kubernetes, the things that let developers run their apps anywhere, they were born and bred on Linux. Then there's the cost. It's free, which is a pretty big deal when you're running thousands of servers. But maybe the biggest reason of all is cultural. The whole open source philosophy of Linux, collaboration, sharing, building things together as a community, that's the exact same spirit that built the modern internet. It's just a perfect fit.
So, knowing how dominant it is in the cloud gives us a pretty good clue about what's coming next. So, where are operating systems heading in the future?
This table right here gives us a fantastic snapshot of that evolution. We're moving away from today's operating systems, where AI is kind of tacked on with assistants like Siri or Cortana, and we're heading towards a future of deep, AI-driven automation. Security is also changing, from old-school antivirus programs to smart AI-based systems that work on zero-trust policies. And we're going from just having some cloud support to a full-blown cloud-native experience that feels the same no matter what device you're on.
And artificial intelligence is going to be the absolute game changer in all of this. Just imagine an operating system that's smart enough to automatically optimize your performance in real time, juggling your CPU and RAM perfectly. An OS that can actually heal itself, troubleshooting and fixing problems before you even know they exist. And one that uses AI to spot and stop security threats like malware before they can do any damage. That's the future we're building.
And that brings us to the final and maybe the most important question of all. As our operating systems get smarter, more automated, and more tied into the cloud, they're going to be incredibly convenient. But they're also going to know more about us than ever before. So how do we find the balance between all that amazing convenience and our fundamental right to privacy? That's the real challenge for the next generation of computing.